Okay, Carla, thank you so much for that introduction. It's wonderful to be among friends, old and new today. And just Yeah, it's a complete honor and pleasure to be here, and I'm glad that we have such an intimate gathering. Maybe we can consider this more like a fireside chat than a lecture. Probably over prepared with the notes, but anyway, we'll have a good conversation, I hope. So today, I'd like to consider how designers use AI and ML to restructure how we access, analyze, and categorize the vast body of historical data surrounding architecture. And I'm thinking about historical data in relatively broad terms, things that we typically think of as historical documents, but also the kind of detritus and remnants and fragments of all of culture that's gone before. How can AI and ML help us navigate the cultural, material, and ecological legacies of the past, and how can it relate and recombine these pasts into fresh ways? So I'll begin with this term spolia. Many of you may be familiar with it, the Latin term for spoils, the fragments or remnants of conquest, conflict, or struggle. It's that which remains after a sort of unthinkable end. The idea is sort of most literally applied to material fragments and the logic of spolia, but the logic of spolia actually mirrors that of the data set. It's images, 3D scans, all of those things sort of constitute a kind of like cultural spolia. On the other hand, there's a complementary concept, which obviously is going to be fundamental to everything we talk about today, which is data. And for our discussion, we'll define a datum as a recorded fact indexed in a larger collection. And a data is a collection of such indexed facts. So both recorded and indexed aspects are essential. A fact that's unrecorded is merely an observation, while a recorded fact that's not indexed to a larger collection is merely a record. So data, as we've taken a sort of linguistic turn in the presentation today, is the plural of Latin datum, a gift or present, something directly given presumably by another. So data sets of physical phenomenon could arguably trace their origins to so-called ephemeris, which were tables of astronomical observations of stars and other celestial bodies that date from the 1st century AD. So since then, data has proved to be a semantically elastic word, taking on all of the valences and meanings that we, of course, associate with it today. So I might add a third term, the portmanteau of the two before, data spolia. So a peculiar product of our current age, data spolia are data that are proxies for spolia or are themselves cultural spolia, ripe to be vivisected and recombined into new configurations as much as physical spolia might be. So machine vision, reality capture, classification, and segmentation processes have made the forms and formats of data spolia almost limitless. So with the right tactics, architects might see these data sets as media in their own right, as well as instruments of reflection on architecture's past. So the presentation is organized into 4 acts. First, scanning the city. So notions of spolia and architectural data are intimately related to how we see and represent the city. In an increasingly digital environment, seeing and scanning the city through machine eyes is an essential way to come to terms with it. And though we think of scanning as reflexively digital, of course there's a whole series, a whole lineage of historical practices that foreshadow in a way the way that we approach scanning today. And those use serialized images, image matrices, to induce coherent views of very complex territories. Likewise, the scale of urban data sets is new, but the basic concept has long been with architecture. In his 1757 pairing of paintings, a picture gallery of views of ancient Rome and picture gallery with views of modern Rome, Giovanni Paolo Panini depicts dozens of nested paintings of then contemporary and antiquarian Roman buildings. It's a kind of Pinterest board of Enlightenment classicism, and it offers a kind of precursor to our more comprehensive contemporary architectural data sets. And what I think is perhaps most compelling about this is that there's actually a world room that's being created here. It's not only a data set, but a spatialization of that data set, which we'll return to. So today, of course, we think and design in image matrices. Vast collections exist for almost every conceivable building type, style, and element. But AI is changing and radically expanding how we as designers understand these images and also imagine our own history through them. So styles such as the Beaux-Arts, which were once communicated through a canon of a few exemplary drawings, can now be summarized through an exhaustive and completely comprehensive data set. So where we once looked to specific examples to convey ideas, we can now encompass them entirely with every instance. So so practices of data design engage with art and architecture's longstanding fascination with the catalog as creative medium. Architects and historians from Serlio to Bannister Fletcher have looked at catalogs as an essential way to map architectural form. And what AI is providing us with is a way to not only organize the catalogs which we currently have in a structured format, but also to create structured catalogs from heretofore sort of unstructured data. So let's see. Oops. So many of the projects that I'm going to show today are emerged from my office certain measures, which Carla mentioned. I have a short trailer to sort of orient you to what you're going to see later. Certain Measures is a studio that designs using computation and culture. We're multidisciplinary systems designers who embrace the possibility of digital media. We're really inspired by how data, computation, and AI can be used to design across disciplines, industries, and scales. From the material to the planetary scale, we partner with companies, institutions, and governments to transform multidimensional systems. We're exploring how water rights are shaping drought, how democracy can be more transparent, and how we'll live in the homes of the future. We look for ways that design and data can change systems for the better through visualization, physicalization, and action. In our work, the digital and physical align to drive systemic and creative transformations. We look at both industrial and natural systems as computational processes, which opens up new ways to connect them and address ecology and circularity. One of our major interests is combining machine vision, geometry, and material analysis to imagine radical new ways to reuse materials from product to building scales. Our process combines speculative fiction, experimental prototyping, software development, and spatial experiences. And at the heart of our work, we tell stories to situate unfamiliar technologies in a social and material world. We're curious and open to the sciences, mathematics, engineering, technology, history, and art, and we aim to create a truly synthetic design process. We work to imagine and prototype a vision of our world in which culture, nature, and technology can all flourish together. We're pioneering a new kind of integrated design that we hope can build a richer, more human, and more beautiful tomorrow. So I thought that Carla's introduction of this session in relation to worlds was very apt, because our process is consciously trying to connect the worlds of culture and nature, and at the same time the digital and physical realities into one sort of coherent set of artifacts, or rather dyads of artifacts. In all of our projects, or most of our projects, there's a sort of imbricated dyad of a physical and media entity, mutually supportive and entwined in their conception, execution, and epistemology. And the idea is to sort of connect these all in a sort of virtuous cycle of creation that uses data as an essential medium of design. So with these vast urban data sets and powerful generative tools, new frontiers in recombinant form open. By developing bespoke software to see and recombine the city, we can gain a much more comprehensive insight into what the city is and what it might become. So how might a machine see and organize the world's cities? How might ML quantify and map the morphological space of architecture? An answer is our machine view of London, which presents a bot for scanning, categorizing, and mapping the shapes of the million buildings in central London. This project is part of an ongoing architectural research project that aims to compare and create a complete catalog of building patterns from cities across the planet. So we've applied this method to London, Berlin, Boston, Liverpool, Tokyo, Shanghai, and several others. In effect, the machine view of the city begins to map out the space of architectural morphology itself. So we're attempting to isolate from this universe of particulars some, I don't know if it's rules, but at least sort of like patterns of aesthetic composition and morphological structure through a relational comparison of every building. So it's really an attempt to actually inventory the entire corpus of architecture and make it legible, interoperable, and comparable. So such techniques have a lot of, I think, important implications not only for the history of architecture, but particularly for the practice of preservation, actually. So data spolia, I would argue, can facilitate new views of conservation that consider entire populations of buildings instead of merely archetypal exemplars. So as a proof of concept, we collaborated with Charles Waldheim at Harvard University's Office for Urbanization to develop a neural model to help identify 18 regional building typologies in various locations in China in danger of essentially redevelopment. So covering a range of areas from Guangdong, Fujian, Hunan, Shaanxi, Jilin, and Anhui provinces, the typologies range from large fortress-like compounds to smaller courtyard residences. And the objective was to build a tool that could automatically scan huge swaths of territory, essentially turn the tools of surveillance towards a more beneficial cultural end. These are typologies which don't actually currently have complete censuses. This was a way to actually effect a census of these buildings. So analysis of satellite imagery could show architects, historians, and preservationists how to trace the geographic distribution of a particular building typology and draw conclusions more accurately about the diffusion of those building types across regions. And moreover, the identification of building outlines can chart morphological variation within a particular typology, or even quantify the range of similarity or difference in the built fabric of a city or region. So really, this was a way to try and make this longstanding practice of sort of comparative morphology somehow a little bit perhaps more scientific, but also at the same time vastly increase its scale. So with the extant plans of our scanned building outlines, we can also infer the interior organizations of extracted building outlines. So on the one hand, we have a series of neural networks that are affecting this classification, and on the other hand, a parallel series which are inferring the particular interior plans. So that provides us with planimetric information on each of those typologies and allows us to essentially infer not only the sort of exterior envelope or understand the exterior envelopes in relation to each other, but also infer the variation of interior properties and spatial conditions. So we can really generate the sort of deep structures of those buildings from those classified outlines. So the collection of these floor plans produces self-organizing maps of spatial relationships. And such a metamorphological chart offered us a glimpse into the natural affinities and similarities, as well as differences among these diverse typologies. So essentially what we're trying to do is kind of like map the world of architecture. And if you look at a repository like OpenStreetMaps, for example, which has nearly every building footprint on the planet currently documented, this is an amazing time to actually reflect on what architecture is. What are the sort of like boundaries and limits of architecture, and how might we go beyond those? So we can take those data spolia and turn them also towards generative ends by using them to train neural networks that might imagine endless cities. So our project Horizons, which now is actually one of the earlier projects in the sort of like generative AI genealogy, I guess, is a journey into an endless elevation dreamed by neural networks trained on these vast archives. The piece represents an infinite panoramic view of catalog data, an endlessly generated elevation, and a catalog raisonné of each new building created by the system. So there's a sort of like complete feedback loop where we have the original data, the generated objects, the classification of those objects, and then the reintroduction of those into the training process. So Horizons invites you to step into a city that bridges human and machine imagination. And I think these sort of like ways of representing world, including things like panoramas, are kind of essential precedents and essential sort of like lenses into these rich and vast and capacious worlds of data. So this process of using kind of Spolia as the base input for some much richer kind of combinatorial approach to architecture, I think we've tried to play out a little bit in some of the student work at the school as well. And so these Spolia are used to create relational assemblages that revisit historical elements in sort of radical new configurations. AI also allows us to think about the remixing and recombination of styles as Spolia in multipolar and meta-modern ways. So in this study by thesis student Ryo Kobayashi, pre-trained models are fine-tuned and augmented, fine-tuned on specific periodizations of Japanese domestic architecture, and then augmented with custom data sets from those historical periods. So standard neural models are thus inflected and extended with a specific authorial hand. And Henry Chung, who's a current thesis student, is using diffusion models to imagine construction details generated from construction waste. So the waste itself, on the one hand, is taken as Spolia, but so also is the sort of lineage of the isometric representation. So at this moment, I'd like to consider briefly the idea of noise. Right? So data is a very structured thing. Noise feels in some ways like it's antithesis. It's a sort of denatured condition of data. So historically, noise was at least partially a consequence of media preservation through what's called the generation loss encountered through iterative copying, for example, of analog media, photographs, cassettes, records, films, and so forth. It's an entropic effect. It's something that's creating where structure is dissipating on some level. But it's also a very particular kind of like cybernetic feedback loop that gives rise to this through duplication, replication, and a kind of genetic drift. AI is interesting because it reverses that process. It's kind of like anti-entropic. You begin with noise and then converge towards higher and higher fidelity representations. It flips the gradient of what you typically think of as information entropy. As continuous and differentiable models, they have the remarkable ability to map any input, any kind of noise, as it were, into a kind of structured and legible and coherent result. And so this is one of the I think kind of like remarkable things about these models is they're sort of sense-making machines. You can feed them complete garbage and they'll create something which is actually feels entirely coherent. So all of these images are actually generated from the same prompt, right? And that prompt, in this case, is this, which is complete gibberish, noise as it were, right? But at the same time, these models are able to produce kind of finely detailed, very specific and coherent sorts of images. So it's somehow like a testament to the fact that from any starting point, you can reach a sort of interesting, sort of curious conclusion. But this also calls to mind actually some of the very kind of Oulipo experiments around language, which were essentially creating something kind of like, I don't know if it's exactly noise, but some random combinatorial process which would create some sort of poetic expression. In some ways, these diffusion models are kind of like a way of making very coherent, kind of like Dada structures from input, which can be completely incoherent. So we're kind of fascinated by this sort of relationship between nonsense sentences, or sort of like paradoxical sentences or paradoxical input, and the results that might come from these kind of diffusion models. So we tried to extend this inquiry recently with a project that we called Twilight Crystalline Models Hunt Wistfully, which is a multi-channel video projection that tests models and language as entangled modes of architectural representation. So the project was partly informed or inspired by linguist Noam Chomsky's grammatically illogical but poetically evocative nonsense sentences, such as colorless green ideas sleep furiously. So Chomsky wrote a sort of series of essays around these kinds of nonsense sentences and what they meant as a way to sort of like reveal the structure of language. It also sort of like extends ideas and notions around impossible objects from perceptual psychology. So the project originated with a purely textual exercise around the creation of hundreds of strange, cryptic, or indecipherable descriptions of models in an attempt to find moments of failure, actually, in these diffusion models' sense-making abilities. Could we find a way for it to create somehow incoherent images? Could we find a way for it to create noise? So the video shows a recombinant image of that process of sense-making. And then on the right, you have this diptych of sort of like the human legible image, and then the machine process, human legible image on the left and the machine process at the right. Now, one subtle but important piece of this visualization is this activation map. So we've talked about maps so far as things which are very expansive. Here we're talking about a map which is very specifically about perception around a specific image. So this activation map shows the machinic view of an image, which is noisy, but also sort of suggests a sort of like level of attention or specificity about what the machine is transforming or attending to at any particular moment. So it's revealing not necessarily the psychology of the machine, but it's revealing something about how it's operating. And we also actually tried to visualize, to the extent possible, the sort of like underlying weights of this very sophisticated matrix operation. So here it's a little bit subtle, but you can kind of see these very light sort of inflections or fluctuations or transformations of the underlying weights as the neural network is converging towards a coherent image. So if we can use AI and machine learning to reimagine architectural form, perhaps we can also look towards insights for better use of material, and in particular, seeing material waste not as noise, but as spolia, something which can be reconstructed or can be reused, can be placed in sort of like a recombinant frame. So architecture and cities are calamitous engines of waste. Our industry has to confront the enormous volume of demolished waste, something like 30% of landfill volume. But what if AI might hold the key to turning this waste into new building? So our answer to that question is a piece that we call Mind the Scrap, which is a data-driven process that designs new structures from existing waste. Using a custom-built 40-dimensional machine learning engine, the project stitches together irregular construction scrap into new forms. Like assembling an unknown puzzle from denatured fragments, Mind the Scrap finds the unique best use of each piece in a new structure through a process of scanning, classification, ML sort of segmentation and computational geometry. So with it, we can match what we have with what we want to build and find beauty and intricacy in neglected waste. So Mind the Scrap essentially uses big data to tackle big waste. So recently we opened a new show in Shanghai that featured a large version of a kind of geometric proof of this process, a fractured, fragmented form negotiating past and future. So this object essentially begins, the architect can sort of like specify a sort of desired form, but then that desired form is matched to the underlying library of scrap that's available. And then as that happens, there's a kind of negotiation between that desire and the sort of envelope of possibility. So we've tried to take a little bit of this process into the field by disassembling existing buildings and scanning their components to create catalogs of waste as a resource. So here we see a disused vacation home from an East German nudist colony that we were gifted, which is deconstructed and exhaustively cataloged. And the forensic scanning process allows us to go beyond the sort of geometric dimensions, which in this case are relatively simple, to also aspects of sort of color, weathering, and with the right sort of tomographic scanner, also certain aspects of structural properties. So this scanning process then enables us to reconstitute all of those fragments into possible new dachas. And we see buildings actually as temporary states of matter whose initial and final states are actually part of the design process. And we can imagine a database of scrap pieces that exists on the digital cloud becoming a sort of shared resource for that project. So here you see sort of like a full-scale fragment of this dacha of the past future, sort of assembled at Futurium, Museum of the Future in Berlin. And one of the things I kind of enjoy about it is that we also have these sort of like fragments of 70s wallpaper which have somehow been Rubik's cubes together. And so there's this idea of sort of like the cultural spolia, even of those interior fragments, which remain and are sort of echoed in this new structure. So we've extended this process to some industrial partnerships as well. So in collaboration with the Austrian concrete company Reeder, we've been using Mind the Scrap techniques to design intricate panels of fiber-reinforced concrete from Reeder's waste stream. So fiber-reinforced concrete is a sheet material. It's cast, and then it's sort of water jet cut. To produce, like any sheet material, often produces offcuts and occasionally waste. So as I mentioned, with all of our projects, there's a sort of like dyadic investigation on the one hand of a sort of like data mapping project, and on the other of a physical manifestation. These are the sort of data visualizations and navigation tools that allow Reeder to sort of like recombine those elements into new panels. And here you can see recently the sort of proof of concept of this project for a new building on Reeder's sort of factory campus. So this is a very interesting process, which I won't get into too much detail around, but for this particular process, we're actually taking a certain percentage of offcuts and sort of waste, and a certain percentage of new material, which is basically wood. It's not exactly new material. It's sort of somewhere between completely new and sort of like partially reused. But anyway, you can see that here you have some very large pieces, which are the original scrap pieces, and some longer linear elements, which are these partially recycled pieces. So yeah, you have this sort of like patchwork gradient effect, which I think is, I don't know, it's pleasant in the alpine environment maybe. So we can look at this process at a sort of larger scale, but also at a smaller scale, at the scale of products. So we have obviously been very inspired by the sort of like Japanese craft of kintsugi, which many of you may be familiar with. It's this practice of sort of like reassembling shattered ceramic vessels with sutures of gold as a process of repair. Now, we're not interested in reconstructing sort of shattered vessels in exactly the same configuration, but rather interested in thinking about that as a sort of pretext for imagining new kinds of vessels. So this project, Kitsuge++, uses our ML process to imagine a machine trained on the delicate art of mosaic. And so the project is a response to the intentional shattering of those kinds of ceramic vessels in very high-end ceramic studios. So we produced a series of these pieces that we couldn't quite afford gold, so we had to go with a 3D print. And so we have a custom 3D printed frame for each of these pieces, which has been, again, sort of reassembled from this ML process. So here you can see a few of the resulting prototypes. So this is also staged as sort of an immersive projection. It allows the viewer to enter this kind of like dream state of the algorithm to be surrounded by this galaxy of fragmented shards in the process of recombination, reconstitution. So many of our sort of media installations are trying to communicate a kind of intuition about what's happening with these sometimes very arcane and very black boxed sort of processes. So, of course, architecture is fitted everywhere with ceramic fixtures. We recently partnered with Laufen, a high-end Swiss fixtures company, to apply these processes to sinks, toilets, and other essential but oft overlooked home technology for an exhibition in Vienna last year. So here you see a similar machinic scanning process of fragments of ceramic fixtures. And the patchwork zones in these reconstructed fixtures actually indicate the use of biomaterials. So one of the things that we're more and more interested in is actually not necessarily the reconstitution of things entirely from scrap, but how can you think of a sort of like hybrid or multi-material sort of assemblage that leverages the strengths or the sort of possibilities of other materials as well. So in this way, we're trying to enable the sort of right to repair and perpetual circularity through data models and generative processes to rematch and reassemble. We were interested in this process of sort of like reuse of spolia down to the level of the ephemera that were used to advertise the exhibition. So these are actually old flyers for the Laufen Gallery that were reprinted with our information. So trying to go all in on the circularity here. So this, eventually we hope to think about the scaling up of this idea to a global material bank, stitching cities together in a common cause to create a more circular and open building process. So this artificial material database, combined with current and future biomaterials, might offer the possibility of a city whose perpetual reconstruction is a living process, a city more alive in every sense than we've seen before. Okay, so as we consider AI not only as a medium of design, but also as an increasingly common embedded capacity of our built-in manufacturing environment, data as a representational medium offers a way to construct worlds in which AI agents are autonomous occupants and shapers of our built environment. So in effect, a post-human condition demands that the design of worlds, or it demands the design of worlds suitable for artificially intelligent occupants. So if we were thinking about AI and ML as a sort of like medium of design investigation representation, now we're shifting slightly to think about, well, what is the world in which those capacities of artificial intelligence are ubiquitous? So autonomous vehicles and robots offer the possibility of a city that's literally reshaped on the fly. In its promotional video for the 360C concept car, Volvo trumpets a world in which autonomous vehicles shuttle passengers safely while the interior transforms itself into innumerable configurations, quote, a sleeping environment, a mobile office, a living room or entertainment space, close quote. The house that travels of its own accord, stuff of myth and legend, is rapidly becoming a tangible possibility with the advent of autonomous vehicles. So autonomously reconfigured homes are part of an ongoing research project in domestic logistics that reassesses the architecture of home on technological and logistic grounds, particularly in relation to artificially intelligent entities. So in particular, is very interested in looking at this history of home robotics, the history of sort of like speculated artificially intelligent sort of compatriots or domestics. It tries to inventory the many ways that autonomous robots have been imagined to transform the home, and also speculates on how those transformations might continue and intensify. So these are a few sort of like house robots, for example, that we imagine could appear in the coming years. So in a complementary fashion, we've undertaken a series of projects that imagine the robotic home as a kind of recombinant urbanism in miniature, a platform for recombinant space. So on the sort of like very geometric level, we imagine these sort of like pirouettes and sort of like synchronized choreographies of domestic robots creating dynamic and recombinant space. But then we also think about how these artificially intelligent entities will have their own loves, desires, passions, hopes, aspirations, and how the space of the home will increasingly become this sort of space of negotiated interactions between networks of agents. So will tomorrow's house come alive? So wondered architect Roy Mason and futurist Lane Jennings in 1969 when they ruminated on the coming computerized home. Riffing on Le Corbusier's famous dictum, they argued, quote, "Today the house is a machine, but with the addition of a computer brain, the house of tomorrow may more closely resemble a living creature or perhaps a collection of living creatures." So this is our project Home is Where the Droids Are, which explores the proliferation of autonomous objects that will surround us and that increasingly define their own trajectories through whatever the analog for life is for them. It asks the question, what if we don't insist on the humanization of domestic technology, but instead animalize it? Here we see a vignette of this future home populated not only by human occupants, but also animalized machines. So if in the previous video I showed a bit of the sort of like human experience of that space, this is the machine experience of that space. So through the lens of machine vision, you begin to sort of understand or gain an intuition about how they're navigating that shared social armature. So in an extreme case, the house could dematerialize into a constellation of choreographed house robots. That's exactly what we imagined with the Berlin buoy, a house composed of autonomous droids. So in the Berlin buoy, every human activity aligns with one or more machine services. An entourage of drones, droids, robots, smart objects, and other digitally augmented devices is matched to the specific actions of domestic life, and then synchronized in a minute-by-minute daily schedule of its occupants. So here we see a spatial diagram of that hour-by-hour pulse of life. Helper drones and autonomous furniture create on-demand sort of living for the occupants. The spatial diagram becomes tangible architecture in the context of the Berlin buoy, which is really more like shelving for these drones than a real house. But it evokes this line from Khalil Gibran, which I found kind of beautiful. Does not your house dream? And in dreaming, leave the city for a grove or a hilltop. So as we imagine worlds shaped by AI, we may well reflect on the role that data will play in the shaping of our future planet. But first, a brief look back. On December 24th, 1968, the crew of spacecraft Apollo 8 became the first humans to witness the shimmering Earth ascend over the barren surface of the moon. Their Earthrise photographs electrified humanity, activating a sense of collective destiny not only between human nations, but with the Earth itself. Historian Benjamin Lazier called this the Earthrise era, when the image of a delicate world could, quote, organize a myriad of political, moral, scientific, and commercial imaginations. Of course, the space age coincided with the information age. At the other end of the call, on mission control, we see a fragmented array of monitors, images, text, charts, readouts that collectively paint a patchwork portrait of the closed world of the space capsule. So what you have are two worlds that are tethered by telematic information processing. On the one hand, an entirely coherent picture, and on the other, this sort of like patchwork assemblage. And I'm always kind of like fascinated by that sort of dichotomy of the sort of like data view of things and the sort of more coherent, somehow human view. At the same moment, experimental media environments brought visitors inside closed worlds of light and image projection, communicating intuitions of increasingly complex world systems in ways quite similar and parallel to mission control. Projects like Stan Vanderbeek's Movie Drone or Ken Isaac's Knowledge Box constructed mediated worlds within the confines of a single room. So we drew inspiration from these data worlds as well as the many planetary architecture of the past century and a half for work on the final project, which I'll present. This is a project which is an exhibit for the newly opened Museum of the Future in Dubai, which I think I'm required to say this every time I talk about the Museum of the Future. It's built to transform our very perception of the future. Okay, there you have it. It's a home for immersive environments that position the visitors in an empowering version of the world of 2070. And so the premise of the museum is you walk into the world of 2070 and experience a range of different environments that try to anticipate that world. So for the museum, we imagined a future observatory for planetary ecology enabled by AI. It's a kind of control room, panorama, and incubator for endangered species developed to address the ongoing challenges of the climate crisis. It's a culmination of a floor-wide exhibit that presents a fictional HEAL Institute, which is an NGO tasked with the gathering of the planet's genetic material, engineering species capable of meeting the challenges of that extreme climate, and redeploying these into the world. So the space consists of two experiences, the geoscope and the nursery. The geoscope is a quantitatively driven global monitoring system that visualizes the progress of bespoke species deployed in threatened biomes. It combines physical models and dynamic projection mapping to show symbiotic interconnections across scales. So you may recognize the term geoscope. So this is a conscious response to Buckminster Fuller's geoscopes, which saw the world as, or which saw Earth as a kind of world game, really thinking about processes of extraction. What we're trying to do is kind of like reformat or recalibrate or reassociate, recode as it were, this idea of a geoscope to center the Earth itself. And to think about this as something which is not extractive, but rather remediative and therapeutic. We see a world in which this geoscope has a replenishing role, in which humans have a vital role. It represents a continuously changing view on a network of monitoring stations across the planet. The coordinating AI dynamically connects with a number of human and non-human agents, connecting them together in a sort of post-human sociology. An integral part of the geoscope are the myriad vignettes that show in zoomed-in detail the thriving species introduced by the HEAL Institute. These include, for example, signal comb jellies and cryptobiotic wildflowers shown here. The geoscope also affords glimpses into the research of the scientists who work tirelessly to confirm the success of re-greening the Earth. So we got to play a little bit of dress up for this, which was actually quite a bit of fun. We sort of demonstrate a little bit the field work that these scientists would continue to engage in to document the progress of those species. And we even witnessed some moments in the labs of careful analysis and preparing those samples for review. So the geoscope becomes an integrated multi-scalar panorama of an optimistic possible biofuture. Now the second part of this experience is the nursery, where visitors peer into incubators nurturing dozens of species that could revitalize a struggling planet. So we collaborated with a geneticist, sort of different kind of data, to design 80 species of plant, insect, and animal, each with special remediating characteristics. The nursery shows the accelerated growth of each of those, enhanced by holographic data profiles of each of the specimens. So drawn from a range of biomes, we imagine species such as nutrient jelly cactus, radiation sequestering flowers, seed dispersal snails, which collectively create a sort of biological menagerie. So this is a supercut of all the physical models. We worked with a highly skilled German art fabricator, ID3D. They're basically sort of doing things that I think is hopefully at the level of a natural history museum, because our thought was that this is sort of like a natural history museum for 2070. Each species, including the microscopic ones, was carefully researched, complete with scientific names, specific climate robust features, and estimated life cycles. So across 7 major ecosystems such as desert, aquatic, Arctic, forest, swamp, alpine, grassland, we imagined the biochemical talents that would be necessary to respond to those 21st century threats, orchestrated by a consortium of humans and artificial intelligences. So, through all these projects, just to conclude, we probed the possibility related to fragments of spolia: digital, physical, biological, spatial, cultural, for certain vocabulary of the future of design. Through data, designers can probe paradox, map pasts and futures, metrize which was what was once unthinkable, and hopefully dimension the space of design itself. Thanks.
Thank you so much for the inspiring presentation and work in general. Simple question about when you were talking about the diffusion models, your use of diffusion models, and how they are, in a way, sense-making machines. I was wondering if in a way, and this is a bit of a speculative question,
the most fun kind.
We could, in a way, think of these models as replicating particular types of, let's say, structures or modes of thinking that have been with us for a long time. And I'm particularly thinking of, particular models in philosophy, such as Neoplatonic philosophy and so on, in Renaissance times, and so in which, in a way, what we do is nothing but recombining and refining sources and meanings that are already kind of contained in structures. And of course, these are widely different worlds, and I'm aware, but in a way, I see certain parallelisms, as if we, from a cultural perspective, we could comment on these models, specifically thanks to these types of experimentations. And we have a glimpse of what they mean generally for our endeavors, beyond the specific technical specificities of how, denoising and so on and so forth. But actually, what do they do with our epistemological structures? And of course, it's very wide kind of comment and question, I'm aware, but I'm really curious about your views on that, in the sense like, do you think, are they helping us push the boundaries to get to new things, or are we, in a way, recombining our sources in different forms?
Yeah, it's a really interesting question, and I think there's two aspects of that. I think first, implicitly, there's this question of, which I think is like it's a very live question, obviously, in philosophy. Is like, is there a theory of mind for AI? Is there a theory of mind for neural networks? And I think it's been an open question for some time. Has become very relevant, I would say, in the last couple of years. One of the things which doesn't answer entirely, but I think begins to shed some light on that question, is this sort of like black box quality of many of these kinds of models makes it difficult to sort of validate or falsify any sort of claims around that. But I think there's been a fair bit of work actually in the last couple of years, and just in the last year especially, where there have been processes which allow basically like the automatic interrogation of models in ways which are not intended to produce something specific, but are rather intended to test it. And so what that testing does is it begins to reveal specific patterns of response, which indicate deep structures within the model itself. And so that's beginning to actually like shed light on what the kind of like, what the kind of like deep structure of those models are. And I think at that point we can begin to say, okay, well, if this model has this particular sort of like characteristic deep structure, this model has this characteristic deep structure, and the two are like not isomorphic, then maybe something interesting is going on. So, again, I think it's sort of like a developing question, but I'm optimistic that process is sort of like essentially feature extraction from the models might begin to give some insight. And then I think there's also this sort of like what you alluded to, sort of like this convexity question, right? So if, even if we have this sort of like vast amount of data, are we essentially just navigating within this sort of like very bounded horizon? And, I think it's an interesting question. I mean, I think there's a question of whether the horizon itself is so vast that maybe it doesn't matter, or like crosses somehow some cognitive threshold where it's close enough to infinity or something like that. But for me, it's actually, I'm probably more interested in asking a slightly different kind of question, because I'm interested in exactly those kinds of cognitive boundaries from a human perspective. So, are there ways that AI can begin to sort of like represent or indicate or sort of help us to understand the boundaries of a discipline as they've existed up to this point and potential ways that it might move forward? So that's part of the reason why we're so interested in these mapping processes is, I'm interested obviously in not only in mapping the space of existing architecture itself, but also even more potentially, the space of terra nullis. It's like, where do you fall off the map? And what does it mean to fall off the map here? So even if AI is sort of like creating, even if it is convex, it's bounding what we've given it and what we've created so that we can better understand where we might go next. So I think this idea of seeing the blanks, the void space here, and the sort of like charted space as complementary and equally interesting, for me that's important, and I think maybe a promising direction to think about these kinds of issues.
I would like to complement what you're asking. In relationship to two projects that you show, the first one on the paradoxical sense-making machine.
Yeah.
So you have a paradoxical input, and then anyway, the output is already produced that we can read sense on that. And then you have your artificial agents. So I want you to if you can make a connection between these two projects, because lately these artificial agents are powered by these large language models, which means that they are supposed to understand our sense. They're supposed to know what we mean. And if you're having these two projects in parallel, how will you, if you could make a link between them, especially with this idea that you're talking about knowledge, which I think they know. Like I agree with Booker saying that now with these large language models, those models they know, and that brings possibility for humans to imagine what will be there if it's already known, since they've read and seen everything. So I really wanted to see if you could map these two projects in a senseless knowing matter. I don't know if I'm making sense. I was reading them in parallel since you brought them to discussion. If you had any idea or your reasoning behind having them in the same presentation.
Yeah. I think it's a really interesting parallel. I mean, one of the things that I am really fascinated by with respect to certain applications of AI is not so much, well, I mean, obviously I'm interested in this sort of like cognitive or epistemic issues of the models themselves, but also how do you think about models whose main function is actually translation, right? So I recently did a piece for AD that talked about this specific application of AI in this sense, the AI doesn't necessarily need to know things in sort of like a very expansive sense. It just needs to be able to sort of facilitate communication between two systems which may be very, very different. And so there's been a lot of really interesting work around the application of those kinds of processes for machine translation of animal language. And this is what I think is actually really interesting about this question of kind of like large language models and their sort of like knowledge status. You can imagine alternate models which are somehow not trained on human language, but are trained on animal language, for example. And the question would be like, okay, well, are there deep structures there which are common, or are they fundamentally different? Are you knowing something differently by sort of thinking through or sort of like representing that knowledge through that kind of language? So, I think that question of meaning then becomes, it becomes a broader question than meaning that might be understandable or legible to humans. It becomes, can you talk about meaning when you're representing these other forms of communication? So, maybe that's to sort of like take the post-human interest. Maybe it's like a bridge too far, but I think it is kind of an interesting question. It's like if you were to think about a large language model based on, whale song, is it going to be something that's fundamentally different? Is it going to tell us something different about reality than what our large language model is? Does it represent a different kind of knowledge? And I think that's also kind of my interest with those agents also, is that they may not be based on large language models, but actually totally different kinds of models which give them a different kind of epistemology in a way.
I'd like to keep asking them. The idea of knowing and communication is built on language, but that's not the only way that we create thoughts or what we imagine, right? So we have different ways that we're storing experiences, and only language is one way to decode that to the world. And I think this is a very interesting way that you're talking about these agents as being able to decode something that is not language, but it's something else. And I would like to ask about, I think your last project was trying to test us on the limits of how we're living in the future. How do you imagine now us, you show us, yes, but could you elaborate a little bit more on this idea of these artificial agents, not in the sense of these big tech companies that are saying a robot will cook for you, but more about be an active agent within your living, within your existence, that is not trying to please you, but is trying to really inhabit the space. Like the house itself, it becomes a space for your agent to actively inhabit together.
Yeah, I think one of the key things, and it's maybe kind of like elementary, but I still think it's sort of like it bears pointing out, is that I think as, we're sort of in like the very early stages of a like Cambrian explosion of AI, right? We have a few different species popping up here or there, but there's still some very large kind of like monolithic models which are taking a lot of space, right? But I think over time, those models will probably diversify further, and we'll really be thinking about, or we'll be living in a society that has a whole range of different agents with very different kinds of capacities. One of the things that we're really interested in is this sort of like idea of sort of like sensory ecology, which is like how do species sense differently? How do they make sense of the world differently? And then the corresponding question of kind of like mental faculties or mental capacities. Inevitably, what will happen is that as these species diversify, we'll be dealing with them in very different tactical ways, and also they'll ultimately sort of engender different kinds of legal rights and political rights potentially. And I think that's a huge open question. One of the biggest open questions I think around AI in the future is like, okay, once you do have these autonomous agents, what does it mean in terms of those kinds of rights? So it goes, it goes well beyond the sort of like question of pragmatics to those sorts of legal status around ownership, around liability and culpability. In fact, I think one of the main reasons why architects will be around for some time to come is that you have to have someone who's legally culpable and who you can punish for things going wrong. And you can't do that with AI, really. So we have that on AI, I guess.
That's a very interesting bridge to the idea of ethics and responsibility that comes to every single AI model that is being released. And if you think about civil engineering, I'm just making a very clear distinction between what's happening with software engineers and civil engineers. Civil engineers are responsible for the bridges. If that collapses, we know who to blame. But now we're living in a world that software engineers are developing these models that are bringing a lot of new ideas, concepts, and even helping in decision making, but non-responsibility is being attached to someone yet.
Yeah.
So I think what you're saying is probably the idea of designing environment is not about only the physical matter, but everything that is being sensed through these agents.
Yeah.
That's very, very interesting. That it comes, if you use those instruments, right? If you use those models, if you are aware what's input output, then you become attached to how people will experience. I don't know if I'm like maybe also.
Yeah, you're imbricated in sort of like a chain of events. And one of the things, of course, people are probably familiar with this like landmark case around Uber and sort of like, or not Uber, around sort of like, what was it? It was like the Google self-driving car fatalities, like the early fatalities from those kinds of experiments. The question was, well, is the software at fault? Is Google at fault? Ultimately, there was a driver in the car who was only there as a safety factor, but they were found as fault, and it's partially because AI is understood as a product still. There are things under US law at least called artificial persons, but artificial and natural persons have very distinct sorts of rights. And so, for the time being, the only natural persons are the people like we see in this room. But it'll be very interesting to see how that develops in coming years.
I feel like I'm about sharing, so please do.
Yeah.
No, I just, I really, really love the work and especially the strain of humor that runs through it. I am specifically a fan of these characters that move around in the house.
A little twitchy.
Yeah.
Yeah.
But I'm curious about this kind of age-old architectural question that does space emerge out of things? Do things, do objects, do active characters, do they engender space? Or is it that there's another level of abstraction where a space hosts these things? And I know that there's no real answer to that, or let's say lineamenta and ornamenta with Alberti as well. So I'm just wondering, how do you see the future of the home? Does it become a landscape of things that become disparate, and I don't know, how do you set boundaries within that? What would be the spatial implications of that if these agents start to engender their own spaces?
Yeah, I think it's a fair question, and I think for us we see ourselves as sort of like transdisciplinary designers as much as architects, and so we're very omnivorous actually in thinking about how these questions could be made relevant in different scales and contexts. But yeah, this boundary between sort of like space and furnishing, I think is a completely apt one. I mean, I think pragmatically over the next years, what you'll see is sort of like a dematerialization of different aspects of the home, but not the entire home, right? There's an armature that will always remain. But I think the interesting question is going to be sort of to what extent that becomes dematerialized. I mean, already most of our entertainment is dematerialized, and there are certain things which will continue that. There's also services which we think about as typically kind of like individual, or sort of like in a specific apartment or house, which can be also sort of like shared, and so there's a kind of like arbitrage that can happen there as well. I think ultimately, look, I mean, we've lived for a long time with sort of kinetic architecture in one way or another. We have doors, we have windows, we have all these things that actually operate in a kind of dynamic way. I think the possibility is that those things will, with this kind of autonomy, begin to rebel. And then that is when things really become interesting, is when we start to have arguments and disagreements with the House, and then that becomes very, very, very messy. Hmm. Yeah, I mean, one of the problems that we were most intrigued by in that sort of set of projects was, how do you take very, very unstructured data and somehow make it usable? How do you create noise and make it data on some level? And so, there's a whole bunch of like tactical questions about how you sort of like scale that up more widely. But the basic premise is that, or the sort of like, the focus of the project is to make that kind of process very flexible and very general and very sort of like adaptable. So to the extent that you are really just sort of like, that you are taking this raw unstructured data, it can come from sort of like a whole range of different sources. So like the feedstock that we were working with originally was actually just like random offcuts that we found. It wasn't, in the case of the reader material, they had a lot of data about what they were actually cutting. But with our first experiments, we were just taking very, very random sets of information. I think where it starts to get tricky, and one of the biggest challenges in this space is like, how do you regrade materials after they've been used? And this is one of the biggest issues around sort of like especially reusing structural elements, for example. There's a very rigorous kind of process that usually has to be gone through in order to regrade that and recertify it, which is really makes this, that's one of the most sort of time-consuming and sort of like cost-intensive parts of this process. So I think that's an area of some very interesting further research, is like, okay, well, how can we think about the regrading of materials in a sort of like efficient and productive way? Because I think other aspects of like the geometric aspects of the problem and things like that are a little bit more tractable, but a lot of that stuff has to be very material specific. But there's a lot of work to be done there.
Maybe I have one more question.
Yeah.
So I've also this Kintsugi project that you showed earlier, and then this idea of Spolia. So I guess an observation would be that these diffusion models sever ties to any kind of data that they have been trained in, and they start blending things together to a level where they become, you cannot possibly unfold them, let's say, to their indexes. And then I'm wondering what would be a possibility of the stories to remain present there? Much like Spolia, for example, it's important that in Venice, that it's the history of the Fourth Crusade and this and that. So you
That's
know
interesting.
where things are coming from.
Yeah.
I'm wondering what would be a take on indexicality, because they completely kind of chop it off, right?
That's a really interesting question. There is some work being done currently around traceability of training data, which I think is, it's very closely related to your question. And I think that's, it's funny because the process of training a model it's an encryption process. Basically, you're taking all that stuff and you're encrypting it into a weighted model. the question is, how can you create something that's sort of like through that process of encryption, which is basically throwing a bunch of stuff in the meat grinder, how can you retain certain aspects of that? And that's an area of research that I don't know a lot about, but I know that there is some really interesting work on that. I think it's related to this wider question in architecture of provenance. There have been a couple of really interesting companies recently. SourceMap, for example, I know is one that's looking specifically like provenance of consumer products for carbon chain mapping and things like this. But there are other applications, and that's sort of it's the flip side of all of this. It's like here we're thinking about how do you sort of like take those things forward, but really how do you sort of like connecting it with these sort of like deeper historical, cultural, possibly carbon chains, I think it's a relevant question. It's related to this question of kind of like regrading, right? It's like, how do you analyze something and determine its provenance later? Yeah.
I might have another question for you, and just following up on Ali's one. I really enjoyed your talk a lot, and I love many quotes, like for example, this idea of like buildings as these like a temporary state of matter, something like this.
Yeah.
You were speaking about how these neural nets, they are these kind of machines that try to make sense out of noise, and there's this like constant process from a noisy and entropic kind of process to like this like trying to recombine again to make something that makes sense, then again like a loss process, and so that this race. And I can think of maybe building as a long-term process.
That's interesting.
Like well.
Yeah.
So like you have a building, it falls into this repair, it's patched up, then things are taken apart, and it becomes a new whole that is made from parts, but like we don't see the parts, we see it as a new whole, one building, and then again it falls into these like cycles. And then what I'm quite fascinated thinking about is what kind of new roles for the architect then open up if one sees oneself in this kind of position of picking up these things. So like what things to pick. For example, when you were showing this project in the allotment, the kind of the constraints of the range of your picking, let's say, comes from a very physical location, and all like trying to make the most beautiful thing out of the things that you find in this place.
Mm-hmm.
If now one thinks that like we are also like if one thinks of spoils, there are of course the spoils that come for very pragmatic reasons, things that are being taken from nearby to build that new cathedral or build that thing out of that old temple that nobody uses anymore. But there are also these spoils that are completely charged with new, like I don't know, like the obelisks in Rome in the 16th century and so on and so forth. So how is this picking process, like picking things, bringing them together into a new whole, things that might be very distant, either geographically or semantically or like from the history, like if you consider and you have a IKEA race and then you put a Ming race next to each other, like really generate something that has of more value or of less value. And I'm just speculating or thinking like what kind of new place do architects can tap or step into when these possibilities open up?
Yeah, I think it's a great question, and also kind of like brings us, I think, to a different linguistic approach, which is, obviously there's this very specific kind of approach to reading and legibility that comes from postmodernism, right? So there's a famous essay by Mario Gendelsonis, which is all about legibility and reading. And I was rereading that essay recently, and he has this very funny moment where he's like, reading, I'm not going to be able to quote exactly, but he's basically like, reading is the antithesis of engineering, and in fact, when you're reading, you're like surpassing those kind of like mathematical processes, for example. And I'm like, well, we're in a moment where actually machine legibility and human legibility are sort of converging. So that dichotomy is sort of no longer relevant. But one of the things that was, I think, that postmodernism sort of like brought to the fore was a sort of sensitivity for those kind of like cultural references. And I think there's an aspect of architecture which, I don't think it was ever lost, but maybe need to sort of like reattune or resensitize itself to exactly those questions of cultural associations of specific artifacts and remnants. So it's no longer about sort of like creating something as a whole which has those sorts of associations. It's about creating like this, or thinking about this sort of like polyvalence that comes from all of those fragments, and when is it appropriate to have those fragments together, and when is it more appropriate to do something that's new in combination with them? I think it's a really interesting set of questions. I mean, I think to answer it precisely, you'd have to think about a very specific project and work it through in a sort of, work through the particulars of that. But one of the things that I think is also great is that you can begin to think about maybe wider or broader sets of meanings for architecture than may have been typical before. And you could begin to think about those sort of like intentional juxtapositions or intentional dissonances, which might then create, which can also be sort of calibrated and refined for specific architectural meaning. So it's, I'm not necessarily a fan of postmodernism, but I do think that that aspect of sort of like semantic sensitivity, as it were, is something that these processes bring renewed relevance to that, and in fact to the whole practice of reading carefully, actually. Reading at a sort of like cultural level.
I'd like to know, thank you for a very interesting answer. I'd like to know what your thoughts on AGI, and if you think you're going to lose our power of agency. And because what I think is more interesting now is not that the AI do all the things and everything, you don't have that conversation, but when you can work with it as a design partner or something, so you could have this feedback back and forth, human and AI. So what is to happen when it comes to AGI? What do your thoughts on that?
Yeah, it's, AGI, we're obviously not at AGI yet, but some of the ways that we're currently working with AI tools, I think will be sort of, will set the stage for how we might encounter or work with AGI later. I mean, already people, Copilot, this idea that AI is sort of like part of the team, it sort of like has a place at the table or something like that. There's already a kind of like sense that that's the case. But at the same time, I think people feel, there's some way in which there's some anxiety about AGI having an almost like omniscient quality to it, and having this sort of like, I don't know, it will be superhuman, but at the same time, I think there can be limits to that, because there are certain ways in which humans communicate that sort of bound them automatically and sort of create some sort of limits. And I think that those AGIs, as they develop, will tend to see them less expansively than we imagine we will now. I can imagine that we see them as sort of like, I don't know if it's co-workers, but sort of someone that we delegate something to, right? An assistant or something like this. And I think a lot of the sociality that currently exists will sort of carry that forward to some extent. I mean, the truth is, I don't know, and I'm very curious to find out myself. Hope for the best, yeah.
So we're running out of time. I want to thank you, Andrew, for your presentation and for your kind answers to the questions.
Thank you.